All right, let's give another chemistry question a shot. This one says a compound containing carbon, nitrogen, and hydrogen is combusted completely with excess oxygen to produce 138 grams of NO2, 22 grams of CO2, and 90 grams of H2O. What is the empirical formula of the compound? So basically here we're creating a compound that has carbon, it has nitrogen, and it has hydrogen. We don't know how much of each of those elements it has. So I'm going to give each of those elements a different little subscript variable. And we're going to try and figure out what those are using molar ratios. I made a slight adjustment to the numbers in the question. Just changed this one to 22 grams to make them work out a little better. But let's try to work through this. So we have to figure out how much carbon, how much nitrogen, and how much hydrogen we have in terms of moles. So if we divide all of these masses by the molar mass of the compound and then multiply by the number of the atom we're looking for, we should be able to figure out how many moles of each atom we have in this situation. So I'll try to figure out carbon first. So we've got 22 grams of the molecule that has the carbon in it. So that's 22 grams CO2. And now if we divide this by the molar mass, we should get moles of CO2. And every mole of CO2 has 1 mole of carbon in it, so that should give us moles of carbon. So CO2's molar mass is about 44 grams for every 1 mole, which is going to give us 0.5 moles of CO2 after we divide 22 by 44. And since there's 1 mole of carbon for every mole of CO2, we also know that there's 0.5 moles of carbon for this situation. So next in order of appearance here is nitrogen. So let's try to figure out how much nitrogen we've got. We've got 138 grams of nitrogen, or sorry, more specifically NO2. Molar mass for NO2 is 46 grams, about, for every 1 mole. So 138 divided by 46 is going to give us 3 moles of NO2. And again, there's 1 nitrogen for every mole of NO2, so we have 3 moles of nitrogen for this situation. And then finally, we've got 90 grams of H2O, which is the compound that has the hydrogen in it. So we're going to do 90 grams of H2O, and water's molar mass is going to be 18 grams for every 1 mole. 90 divided by 18 is 5 moles of H2O, but we've got 2 hydrogens in every water molecule, so we have to multiply this by 2 for the number of hydrogens, which gives us 10 moles of hydrogen. And then finally, to figure out the ratios between all these numbers, we typically divide by the smallest number to get the simplest ratio of all of these different values. We'd rather not have a decimal, and this is a decimal. So if I divide, so A is going to be 0.5 divided by 0.5, which is 1. Our B, which is our subscript for our nitrogen, is going to be 3 divided by 0.5, which is 6. And then C, our 10 moles of hydrogen, we can divide our 10 by 0.5, which is going to equal 20. So our compound should have these subscripts. So take out A, take out B, take out C, replace those with our numbers we came up with. So that's 1, 6, and 20. And this should be the empirical formula of our compound right here.